Hi, myself Durga Prasad. I am giving a seminar topic on flip-flops in digital electronics of STLD seminar. Now we are talking about the RS flip-flop, JK flip-flop, T flip-flop, and D flip-flops with truth tables and logic diagrams. First one is introduction to the flip-flops. The flip-flops are mainly used to store the 1-bit data. To store only 1-bit data. We have a different types of flip-flops. We are designing the flip-flops by using NAND, NOR gates, universal logic gates, and are nothing but latches. We have a 3 types of flip-flops: RS flip-flop, JK flip-flop, T flip-flop, and D flip-flop. By using these flip-flops, we are used in by storing data. We are used in the memory elements, registers, counters, and sequential logic circuits, etc. But it have only 2 states. First one is set state and reset state. Set state is nothing but 1 and reset state is nothing but a 0. Now we are talking about the RS flip-flop. RS means reset and set flip-flop. In this flip-flop we have a 2 inputs, S and R, and a clock signal and clock signal. And we have a 2 outputs, Q and Q bar. Q is first state and Q bar is complement of the Q. And this one is an SR latch. By connecting to the 2 NAND gates to the SR latch and giving the clock, it is nothing but a RS flip-flop. In this RS flip-flop, we using this is called clock. This is clock where we give edge tickering nothing but it have like this, and nothing but a level triggering. By using this edge tickering, we use RC differentiator. This is like nothing like this. E and RC differentiator by giving the edge tickering. Now see the RS flip-flop truth table. When you giving the 2 inputs are low, S and R, the output is no change. That is making no change condition. When you giving the 1 to the S and 0 to the R, nothing but a set condition. It is in set condition. Or we can give the 0 to the S and 1 to the R. It is nothing but in a reset state. For example, if you S have a 0, it is in reset condition. That means R have a 1. If you S have a 1, it is in set condition. Otherwise, if 2 inputs are high, that means it is in indeterminate state. It is either set condition or reset condition. We are going to the JK flip-flop. In the JK, we are going to the JK flip-flop due to the by overcome the invalid state. To remove invalid state in 1 inputs in JK. If J equal to 1, K equal to 1, the output is toggles. Toggles means it may be 1 and 0. Changes within seconds. 1 to 0, 1 to 0, 1 to 0, 1 to 0. That is nothing but a toggle stage. In this now we are talking JK flip-flop truth table. When you give it is same as a RS flip-flop, but you give another input this way, another way to the Q bar and J to the Q. By connecting these 2 wires, it acts as a JK flip-flop. In the JK flip-flop, we give edge triggering for efficient output. Are we giving the level triggering also? When you give 0 to the J is nothing but a set condition and K is nothing but a reset condition. That is J equal to R, J equal to S. J equal to S, K equal to R. When you give 1 to the when you give 1 to the J and 0 to the K, it is in reset condition. Set condition. That Qn equal to 1, it is nothing, Qn is nothing but in a state, Qn is present stage. Understand? When you 1 to the J, it is in set condition. 0 to the K, it is set condition, and 1 to the K, it is in reset condition. when you j equal to 1, k equal to 1, it is in toggle stage. That is nothing but 1, 0. When you connect it to the JK flip to the LEDs, the LED on and off, on and off, on and off, on and off, on and off in within few seconds, milliseconds or microseconds. Now we are going to the toggle flip flop. See, in this toggle stage, we can remove by using giving a joystick ring or by giving the master slave inputs. When you give master slave inputs to the JK, then the toggle stage will be removed. In this T flip flop is same as a JK flip flop, but we can join to the both J and K. Why you are joined to this K two inputs? That is, when you have only two inputs, 1, 0. If you giving 1, it is in set condition. If you giving 2, 0, it is in reset condition. That's why we can join to these inputs. When you giving 1 to the T, it is in set condition. If you 1 to the K, T, it is in set condition. If you giving 0 to the T, it is in reset condition. And giving edge triggering. Why you giving edge triggering? By you remove the toggles. By you remove toggles, we can give edge triggering. Now seeing the truth table of T flip flop. See, in 0, 0 condition, nothing. It is no change. Sorry, in 0 condition, it is no change. When you giving 1, it is in set condition. It is in set condition. When you giving 0, it is in reset condition. This Q is in present stage. Present stage is 0. What is the next stage? 1. And Q is giving it is reset condition. And next stage is 1. If you giving 1, 1, that means toggles. Toggle is occurs due to this toggle 1. First one is 0. Present stage is 0. And next stage is 0. Present stage is 1. And next stage is 0. If present stage is 0, next stage is 1. That means changes 1 to 0, 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 1 to 0. This is known as toggle stage. Only by using the T flip flop, we can only one advantage. In T, in J, in K. Join to this. When using JK flip flop, we have two inputs. When using T flip flop, we have only one input and two outputs. We can decrease the number of inputs in T flip flop, and efficiency is high. And we have highly used only T and JK flip flops in counters, memories, registers, shift registers. Mainly use these two flip flops only. Otherwise, you can use the data flip flop. Data flip flop is same as RS flip flop, but you giving the join these two R and S. So this one is R and this one is S. You can join to this by using the NAND gate. Sorry, not gate. Of complement to this. The simplest type flip flop. RS D flip flop is simplest type flip flop, and it have only single input data. Single input can D is nothing but data or delay. Single input D. Output follows input after clock page. After we giving clock, this you can use level clock also or edge trigger. You can give any clock also, edge clock or level clock. In this D flip flop, we can give 1. The output is set condition. The flip flop is in set condition. When you giving 0, this is in reset condition. Same as RS flip flop, but we can join to this flip flops only. When you give 1, the what is the set? 0. This is giving R to the 1, they have 0. That's why it is set condition. When you giving 0 here, complement of 0 is what? 1. That means it is in set condition. It have no any toggle input by if you give only 1 and 0. If you giving 0, it converts to the 1. Okay. See, data through table, when you giving 0, it is in set condition. Present stage is one is set condition, another one is reset condition, and one is this like this. Thank you. This is all about the flip-flops. What we are discussing in this class, flip-flops R, J, K, and T, D flip-flop. We have mostly used J and T flip-flops only. For simply use, we can use RS flip-flop or D flip-flop. This is all about the flip-flops. Thank you.